Now the next algebra word that we need to be aware of is the word substitution. Now in life, the most common use of the word substitution or substituting is probably in sport. And I have to say this is not my area, but as far as I'm aware, a substitution in a sports game means you take one player off the field and you swap them out for another one. Well, that meaning kind of carries over into the algebra stuff that we're doing here. When we've been looking at the simplifying, we've often run up against a point where we've got to our simplified form and there's nothing else that we can do with that without having some more information. Well, this is the some more information. We'll have a look at two different questions with this, and here is the first one. Let x equal 4 and y equal 3, and then work out 2x, 5y and 6x plus 9y. We are given some extra information here. Here we are told the number that x is coding for and the number that y is coding for. What we're then going to do is, for each of these expressions, the 2x, the 5y and the 6x plus 9y, we are effectively swapping out, substituting the letter for the number that we now know it to be. For example, 2x, well that means two lots of x, but we now know that x is in fact 4. So we swap it out for the number 4, i.e. 2 lots of 4 is 8. 5y, well that would be 5 times y if we were to put that times back in, but we now know y to be 3. So we swap the y out for the number 3. 5 times 3, 15. And 6x plus 9y, well we can do exactly the same thing with those. If we think about the 6x first of all, well x is 4, so 6 times 4 that would become is 24. And we can think about the 9y, well that will be 9 times y is 3, so 9 times 3 is 27. And our question then becomes, we do what we need to do with those numbers, so it will be the 24 from the first bit and the 27 from the second bit added together, because that's what we're told to do in the middle. 24 plus 27, or 51. We could look at some more complicated things than this as well. And if we have a look at 4 more, for the same values of x and y, x equals 4 and y equals 3, let's work out xy, x plus 2y over 2, 3x squared and 3x squared. There is a difference between those last two, we'll come to that very shortly. Well, xy would simply be, well, x is 4 and y is 3, and what do we need to do with them? We need to times them together, because hidden between these two, x and y is a times sign. 4 times 3 then is 12, and xy would equal 12. X plus 2y over 2, let's do the top line first. So on the top we've got an x, that's 4, and we've got 2 lots of y, so that would be 2 lots of 3. All of that divided by 2. So on the top, 2 lots of 3 is 6, plus the 4. Notice that we're following our BODMAS rules here. That will be 4 plus 6 on the top, all of that divided by 2. 4 plus 6 is 10, over 2 comes to 5. 3x squared. Well, what this actually means, if we were to stretch this out, is 3 times x squared. X is 4, so x squared will be 16. 3 times 16, and 3 times 16 would be 48, where the x squared is being swapped out for 4 times 4. And then this last one finally. Following our BODMAS, we'd do what's in the brackets first. So inside the brackets we'd have 3 times the x is 3 times 4. And then we'd be squaring all of that. 3 times 4 in the brackets is 12. We're squaring that. 12 times 12, 144. What's the difference? They're actually just two different things. According to our rules of BODMAS, these are just numbers, remember. X is code for a particular number that we do know this time. In the first one, we'd have to do the squaring first, the powers come first, and then the timesing of the 3 times comes second. And in the second one, the bracket comes first, so we do the 3 times the 4, and then we do the power next. The volume of a square-based pyramid is given by the formula volume equals 1/3 LWH. A pyramid has height a h equals 9 centimetres, base width w equals 4 centimetres, and base length l equals 4 centimetres. Work out the volume of the pyramid. Now, do we know how to work out the volume of a pyramid? As in off the top of our heads? No, we don't. But luckily, it is given to us here. We are told that the volume is 1/3 LWH. That is a formula. What is a formula, you might ask? A formula is a fancy word for a rule that will work every single time. This particular formula happens to have been written using algebra, but a formula could be given in words. And we have to be able to work with formulas. Or formulae, if we're being more proper. Key thing with this question is we do not have to know how to work out the volume of a pyramid. All we have to do is be able to understand how to use this particular formula. The formula is given to us that what we do is we work out the volume by doing 1/3 LWH, which is a little bit messy. So why don't we use what we know about algebra to rewrite that? Why don't we, in fact, put the times signs back in? And that would be 1/3 times L times W times H. And handily, we are given in the question a value for h. The height h is 9 centimetres. We are given a value for w. The base width w is 4 centimetres. And we are given a value for l. The base length l equals 4 centimetres. Which seems pretty useful to me. Because that means that all this is a substitution question. We simply swap out the values of L, W and H that are given to us, and we work out the answer to this particular thing. It's a substituting question, just with a proper rule that's actually the way to work out the volume of a pyramid. So what we need to do in this particular one is we would need to take 1/3. We're going to swap out the L for the value of L, which is 4. We're going to swap out the value of W, also happens to be 4. And we're going to swap out the value of H, is 9. 1/3 times 4 times 4 times 9. Maybe we want to pop that in our calculators. Say we could do 1/3 times 4 times 4 times 9. And if we pop that into our calculators, we would hopefully come out with an answer overall of 48. Well, 48 what? If it's a volume, it will have to be centimetres cubed. 48 centimetres cubed.